Okay, so what we've got here, sorry about the vacuum cleaner. Well, here we've got our two cubics. This one, we've got intercept here at -1, and we've got, what do we call this thing? A turning point at +2. This other one here, we've got a point of inflection. So we're going to write them in two different forms. This one, we're going to write in factor form. So that's what we're going to start with. So, where's Kaz? So we're going to say define h, because we used f and g previously. Whoops. Define h of x as, we're going to put this in. So we've got a factor here at x plus 1, because it's a -1. We've got a times x plus 1. That's that one. And then we're going to do, we're here at 2. So we're going to say, oops, times x minus 2, because it's a +2. But then we've got it here, we've got a turning point there. So this needs to be squared. And that's what we've got there. Now we're going to substitute this point here, 3 and 2. We could do 2 and 0, but we're not 100% sure that's what it is. So we're going to do 3 and 2. So now we're going to say solve h 3 equals 3 equals 2, and we're solving that for a, and we end up with a half. So that's what we've got for that one there. So that's the steps we take. So that's with that one in factor form, and we've got the repeated factor, so we've got that squared. This one, what do we notice about this? What is this -1, 2? What do we call that point? That is our point of inflection. So we need this in point of inflection form. So we're going to say define j of x, doesn't matter what we call it, equals, and now in point of inflection form, a times x minus h. Oh, we've already got h there. Oh no, because I'll call that h. Let's start it again. Nope. Okay, define f of x, now I'm using f again, a times x minus h, all cubed because it's a cubic, and I'm saying plus k. And now I'm going to have -1 and 2. Now before we go on, what do we notice about this cubic? It's different to this one. This one went this way, this one goes this way. So this started out, this has a gradient positive, negative, positive. This gradient is -0, negative. So this graph, we're going to have a negative value for a. Let's see how we go about solving that. So we're going to substitute these points, -1 and 2. So we're going to say minus -1. I'm going to say 2. Let's just say f of x. Okay, so you see they're all positives here. So it's because we've said -1. But what we could do, just to keep track with what we've been going through, we've got a negative value of 1. So we've got a value at -1, so we're putting that in there. Okay, now it's done. So now from there, we're going to substitute this point 1 and -2. So we're going to say solve f -1 equals 2, comma a. That's what we're solving for, we're solving for a. So we're substituting this point, and we're working it out. Shh.
Daddy, can you use the lid of this game?
There you go. Oh.
But Daddy, you have to make it to stand up.
Can you ask me in a few minutes? There you go. Off you go. Please close the door. Bye. Sorry about that. I had a 4-year-old asking me for help. Okay, so from there, we press... Oh, that's odd. Saying that's true. Why isn't it solving for A? Solve. True. Solve f of 1. Oh, it's 1, not -1. F of 1. 1 is -2. I don't know all these brackets. Sometimes we get distracted. Okay, so there A is -1/2. So that's what we ended up with for that one. So that is how we solve equations on GAS for when we're given a graph. So there you go. If you have any questions, send me another email. But my advice to you is just sketch stuff. So say you sketch this or even this one. So sketch some of these and then look at what you get. So with this one, you should get maybe 3 intercepts, maybe 2, I don't know. Once again, 2 or 3 for this one, I don't know. And then try to work backwards and see if you get that equation. But once again, if you have any questions, send me an email and I'll see what I can do in this limited time that we've got.